How's it going, ladies and gentlemen? Mr. Donahue here once again. This time we're going to take a look at 1.3, properties of matter. So our objectives will address chemical, physical, intensive, extensive, changes of state, separation of mixtures, so those kind of properties of matter. So intensive and extensive properties. These might be new vocab terms for you, but they're not that scary. All right, so intensive properties depends on the identity of the substance, not on how much sample is there. So intensive, think identity. It's both the words that have I in it, right? So it just depends on what it is. So things like melting point, right? It doesn't matter how much ice you have or how much water you have. The melting point is always going to be the same. Density, same deal. Refractive index, it's always going to be the same regardless of if it's a tiny little piece of glass or a whole pane. So this is going to help in identifying what the substance is, because even if you have a little bit of it, the melting point is going to be the same. So you can always use that. Whereas extensive properties are the opposite. It depends on how much stuff is there. So, the mass or the weight, it depends on how much you got. Do you have a little bit or do you got a lot? The mass is going to change. Same thing with the volume. So extensive things depends on how much is there. So intensive or extensive properties, right? Let's do a little practice. Ask, does it depend on the identity or the amount present? If it's the identity, it's an intensive property. If it's the amount present, it's an extensive property. So if we talk about the mass of 26 grams, well, what kind of property is that? Well, 26 grams it's a mass. It depends on how much is there, so it's going to be extensive. Density of 1 gram per milliliter, well, that's the density of water, and it will always be that for water. Liquid water, I should say. Doesn't matter how much water you got, a pool worth or just a cup. The density is always going to be that. Temperature of 27 degrees Celsius. Well, again, that isn't going to change with how much is there. It's the temperature. If you got a cup of warm water or you got a whole pool of warm water, it doesn't matter. It's still the same temperature. 1.5 meters long. Well, that definitely depends on how much is there, right? So that's going to be an extensive property. Blue in color. That is going to be intensive because it doesn't matter how much is there. It's just what it is. It's blue. Viscosity. Again, that's going to be an intensive property because a little bit of honey has the same viscosity as a tub full of honey. Other properties. So let's talk about physical properties. Physical properties can be measured without changing the identity and composition of the substance. So things like color, density, melting and boiling point, or solubility, all those would be physical properties because you can look at it without changing what it is. You can measure its density without changing what it is. You can melt and boil it and not change what it is. You can also dissolve it and not change what it is. This one tends to be a trickier one for people to think about because, like, when you dissolve salt, it looks like it disappears. It's still there. It still has the same properties. Like, you can taste the salt in the water. The salt didn't change. It's just dissolved. Whereas chemical properties are different. So they describe how a substance may change or react to form another substance. So flammability, when you're burning something, you're making a chemical reaction and you're making new substances. So that's a chemical change. Heat of combustion, well, that has to do with, again, a chemical change. So it's going to be a chemical property. Oxide formula, so basically when it reacts with oxygen, what is the thing that you get? Well, that's a reaction, so that's going to be a chemical property. And just reactivity in general, like is it highly reactive or is it stable? We're talking about chemical changes, so it's going to be a chemical property. So let's take a look. Water, for example. Let's take a look at some properties of water. So physical properties of water. Well, the density of liquid water is 1 gram per milliliter. The boiling point is 100 degrees Celsius. When you boil it, you get water vapor. It's still water. Its identity didn't change. Freezing point is 0 degrees Celsius. When you freeze it, you get solid water or ice. It's still the same thing. And dissolves many solutes. So when things dissolve, that's a physical change, right? So because it's a physical change, it's a physical property. So if we take a look at chemical properties of water, well, its formula is H2O. There's 2 hydrogens bonded to 1 oxygen. So that's a chemical thing. The pH of 7, well, pH has to do with like chemical reactivity and stuff. So that's a chemical property. Yeah, so let's talk about physical changes and chemical changes. So physical changes the physical appearance, but not its composition. So phase changes, right? It's still the same thing after it melts or when you boil. It's just in a different phase. Dissolving salt. It's still salt, but it's just dissolved in water. You didn't change its composition. You maybe changed what it looked like, but it's still the same composition. Or making mixtures. You know, when you mix two things together, there's no chemical reaction. It's just a physical change. Whereas with chemical changes, we have a change into a new chemical substance. The composition changes. So when we combust something, right, like maybe we got methane and we react with oxygen, we end up with new compounds, right? This is a chemical equation. There was a reaction there. Oxidation, same thing. Rusting, same thing. So we're talking about new substances forming. That's chemical change. So let's take a look and talk about separating mixtures. So mixtures are physically combined so multiple things combined physically. They're not chemically reacting, they're just mixed together. So because they're physically combined, each component retains its own properties. So if I were to mix in some salt into some water, the water still has the same properties and the salt still has the same properties, but they're mixed together physically. So because they're physically mixed together, we can use the differences in properties to separate them from each other. You know, what is different about salt and water? How can we use those differences to separate them? So let's take a look at some examples, right? So if we have an iron and gold mixture, all right, how are we going to separate these things? What's different about these things? Well, first, color, right? You could painstakingly go through your mixture and take out all the gold pieces and separate them from the iron just based on color. You could also maybe use magnetism, right? Gold isn't reactive to a magnetic field, but iron is. So maybe you could use a magnet to pick up all the iron stuff and leave the gold behind. Reactivity with acid. Well, I know iron will react with acid and gold won't. So if I poured acid into that mixture, it could dissolve all the iron and leave the gold behind, and I'd be able to separate them by filtration. I could, pour through a filter, the gold will get stuck, and all the reacted iron will pass through. What about coffee grounds and water? Maybe something you guys are a little more familiar with. How could we separate them? Well, what's different about their properties? Well, we could talk about particle size. Coffee grounds are relatively large and water molecules are really small. So we could use filtration. We have like maybe a paper mesh kind of thing going on where there's a lot of tiny openings that are too small for the coffee grounds but big enough for the water pass through. And that's basically what filtration is. What about salt and water? That might be a little tougher because, you could pass salt water through a filter. The salt and the water both make it through. So how are we going to separate those things? Well, what's different about them? Boiling points are different. Water has a much lower boiling point than salt, right? So water boils at 100 degrees Celsius and salt won't boil until over like 2600 Celsius. So if you heat up a mixture, the water will boil and leave the salt behind. So now the vapors could be collected and condensed back into the liquid state. And that's what we got going on here. We have some heat being applied to the salt water. The water vapors evaporate, and then they cool off in this cooling tube and condense back into a liquid, and we can collect that. And that's distillation. That's what we call this process. Separation of mixtures, extended pigments, and inks. So you might have done a lab like this if you ever took like high school bio and you're like, we got this plant extract, you're trying to separate the components. You can do this with water-soluble inks, washable markers. So what's different about all of the inks or the pigments in the ink? Well, we could separate them based on solubilities. So ink is actually a mixture of different colored pigments which have different solubilities in water. So you can use chromatography to separate the pigments based on those differences. So right here we have like non-polar paper and we have polar water. The water is going to travel up this paper and it's going to keep going. And what's going to happen is the really polar pigments are going to hang out with the water like the whole time and travel just as far as the water, whereas the less polar or the more non-polar pigments are going to stick to the paper more and not travel as far. So you can separate those pigments that way. And that's pretty much what I was just saying. So there you go. So summarize, what are the differences between intrinsic and extrinsic properties, physical and chemical properties, physical and chemical changes, and what are some separation techniques and how do they work? So you should have a basic understanding of how filtration helps with separation, as well as distillation and chromatography. And that's it. I hope you found it helpful. See you in class. Okay, bye.